I'm Pam Hoffman, Everyday Spacer.
I'm Jeff Miller, CME Computer and IT Solutions.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 5 a.m. on Saturday in London. We're broadcasting live from a very windy Thousand Oaks, California. Thank you so much for being here. Let's take some comments.
Yep, and there's Janie.
Hey, Janie, welcome.
And there's
Hey,
Dawn.
Dawn, welcome. We're so glad you're here.
Hey,
and
Scott.
Hello. All right, so tonight's episode is a crunchy topic. We're calling it Expanding Universe. We'll be back in 8.3 seconds. There's a link to that book in the description. If you want a signed copy of the book, write to, let's go there and get it, Pam at everydayspacer.com for details. A new study shows that the universe's expansion may not be accelerating. For the past several years, scientists have seen glasses. I need new glasses, I think. That using the light from Cepheid variables, also known as standard candles, the universe appears to be expanding. They have then added a bunch of fiddly bits.
Well, no, the expansion has been accelerating.
Accelerating. Okay, we had the wrong word then. They've added a bunch of fiddly bits to make all that work. So, oh yeah, there it is. To explain why the expansion is accelerating. Except that the standard candle may not be so standard. It does seem that their luminosity varies, but it varies predictably. So they are still useful. We just have to learn how to adjust the measurements that they give us. And that makes sense because we always use magnitude and apparent magnitude. Anyway, Jeff, make some sense of this, please.
Yep. Well, first.
Oh, Mark.
Hello.
Welcome. Hello.
Viewer. Actually, could you write what? How do you want us to call you? Can't parse it from the name put together. So if you don't mind, just what would you like us to call you?
That's great.
And so let's get right on to it because this is what I saw, and the title is kind of clickbaity, but it is on phys.org, so it's it's gonna at least relate to what's in the article.
So it's a serious site, but and who can blame them? Yeah, everybody wants clicks, right?
Yep. So the universe's expansion is now slowing, not speeding up, which kind of makes logical sense. But one of the issues is that the Cepheid variables, or the what is it? What?
AI decided to say it two different ways in the teaser video.
Oh,
that was wild.
Yeah. They've been saying that they kind of created dark energy to explain the increased acceleration, or the accelerating expansion of the universe. Mm-hmm. And now they haven't actually shown that dark energy isn't needed, but it's not as much as they thought. Basically, type 1a supernova, Cepheid variables, standard candles. They basically have shown that those nova, basically their luminosity does vary based on the age of the star that produced them.
I was wondering why Cepheid variables were sort of like considered this standard thing.
I think
it seems like it would be.
I think all the nearby ones were from the same age. So if they were in a galaxy that we could measure through other means, they were fairly similar in composition. But the older ones would have had much bigger stars. So there wouldn't be as many inclusions in the mix. It'd be basically hydrogen and helium. None. If they're like first generation stars, there wouldn't be any mix of even irons or calciums or anything like that.
Because that's comes from supernova. So the
or
very
at least
first
through the production, like calcium comes from production in the star itself. But
yeah, but they have to
and iron
get out into the universe by
right, yeah, that
explosion.
has to boom out, yeah.
Yeah.
As the heavier elements are created in the nova
Yes.
itself. So they found that it now this study says that it can vary, and again,
This one.
yeah,
Okay.
it's a study, so we need a lot more to actually say for sure. But and I'm going to put a link to this one in there, and all of the other ones that I get you can rabbit hole to all of the other ones that I'm going to show you from this one link.
So there's links in here. Oh, hey, Naomi's here. Welcome.
Yeah.
Glad you could make it. We're just getting started.
Yep.
Perfect timing. Yep. And that link is in YouTube because the Facebook pages have failed yet again.
Yep.
I think I will change the ones. I should tell them to. Anyway, so yeah, that link is clickable in YouTube. It looks like it didn't fall apart. Some of them break. But yeah, looks like you can click on that and go to that article.
Yep.
This one here.
Yeah. And based on a much larger host galaxy sample of 300 galaxies, confirmed that this effect is at extremely high confidence, 99.999. So,
wow.
3 nines, suggesting that the dimming effect of distant supernovae arises not only from cosmological effects, such as being far away and having stuff in the way, but also from stellar astrophysics effects. The Lambda CDM cosmological model, with the systematic bias corrected, supernova no longer matches the standard cosmological model with the cosmological constant.
That's a good chart.
Yeah, I'm going to blow that up some.
Good.
So this is before correction of the Cepheid variables, and it matches this cosmological constant, which they kind of created to match the Cepheid variables. So
there's the fiddly bits.
Yeah, and basically, according to the theory of time varying dark energy, so they haven't gotten rid of dark energy, just that it kind of interacts with itself and lessens over time. And I'll get into some of those articles later because this one references them. But after the correction, it follows this much closer than it follows this cosmological constant.
Right.
And so it's not quite there. There's probably something else going on too. In fact, I really don't like time. I don't like dark energy in the first place. Okay. Because it's something made up to account for what we're seeing. So I don't like it. But hey, if it's real, it doesn't matter if I like it or not.
Well, a lot of times we've seen that kind of thing. They add fiddly bits to make it work, and it's often the simplest answer is in fact the correct one. So.
Yeah, in the Earth-centered universe, in order to make the orbits of the other planetary bodies come out correctly, they had to add fiddly bits to the orbits to and
very fancy orbits.
And the more they studied, the more fiddly bits they had to put on the fiddly bits.
Until someone Copernicus really.
Yeah.
Said, hey, wait a minute.
So that kind of seemed like that's what we were doing here. Is that we were adding fiddly bits instead of having a better understanding of what's going on. And thing is that unless we figure out what else is going on, what's the thing that we're missing completely, all we can do is add fiddly bits.
The one thing I hope is that they will in fact decide that there are ways to change.
Right.
Because they were convinced that the Earth was the center of everything for a very, very long time.
Yeah.
People were excommunicated from the church, all kinds of crazy stuff.
Well, even before the church, there was probably bad stuff that would happen because everything you saw, it weren't around the Earth. Of course, if you didn't measure really carefully, that's what it looked like. You know, so now the fact that Mercury would go partway reverse and come back might have been a bit of a head scratcher for them.
People still talk about, well, Mercury's in retrograde, so all the machines are going to go, wah, haywire.
Yeah.
Okay.
Yeah.
I don't argue.
Yeah.
You ready for more?
Sure.
Okay.
So they used the DESI project and just basically they used a lot of tools to look out there and see.
So it says dark energy spectroscopic instrument. That's DESI.
Right.
Which
and
is
so
DESI, what he said.
Yeah, so it's out there to measure the dark energy, and that is actually what got them into thinking that the cosmological constant wasn't real.
Okay.
And now and they actually go back to this thing here. Data from dark energy observations may end in a big crunch. This is, the measurements of the galaxies and stuff where they were trying to measure the dark energy showed that it was likely that the accelerating expansion wasn't real. But they didn't have a smoking gun. They didn't have this is kind of the way it can be explained better if it's not real, but it's not like we didn't disprove it. Now, if the 1A supernova are shown, now they say it's 99.999% chance that that's what's going on.
Odds are good.
Odds are good. But I think that they need other eyes on it, maybe other ways to measure the same thing, to basically take it out to a couple more nines, make it much more likely to be true, because every time you test something and it ends up not disproving it, makes the theory stronger. Still, it's not fact. I mean, you can't go out there and take a yardstick to it or something.
Yeah, it takes only just one experiment to refute the whole thing.
Right, yeah.
No matter how many times you've done it before.
And that might have because we've been talking about the accelerating expansion for about 20 years now.
Hey, Cliff is here.
Hi, Cliff.
Hey, Cliff.
Yeah.
Welcome. Glad you're here.
And for those 20 years, I've been saying, I really hope this isn't real. Because it
seemed odd.
Yeah, they put a cosmological constant on there just to make the equations work. It's like, that's not the way you do science.
Yeah, ever since the whole thing with the Earth orbiting the sun kind of deal, is like, yeah, anytime they want to add fiddly bits, I think that's suspect.
Yeah. So
personally. Back to
yeah. So they're saying that the universe may end in a big crunch in 33 billion years. They've actually measured through the dark energy measurements. They say that the universe will continue expanding for about 11 billion years.
Wow.
Then it will begin to contract.
Interesting. I mean, clearly it won't really bother us too much, but
right, yeah, it's going to be a while.
As we're damn near the middle of the process. That's
right.
That's what I think is so interesting.
Right, yeah. And so, yeah, we're kind of halfway through the expansion. So now again, these numbers are just what they've calculated. It's not, I'm gonna, give these a grain of salt, but I like these numbers better than the other ones. Is that any kind of evidence for anything? Not really, but I like them better. They match what I think is more. They match the Occam's razor, which
is more likely
yeah, because less fiddly bits, less less needed stuff.
I like it.
Now they do say that dark energy is there, and remember, dark energy isn't an identified thing. It's not like
it's a placeholder name for whatever it is that's
whatever it is that it is, because they don't know. All they can do is, it's kind of like an elephant in the dark. If 5 guys with an elephant in the dark, they reach out and they touch something and, well, it's got to be this or it's got to be that.
think
But
some of them are a wall or a
yeah,
tree or a snake or
yeah,
depending
exactly.
on
What
which
they
part of
touch.
the elephant.
Yeah. So, it's right now this is just our first touch on it,
Okay.
or maybe second or third, but still, I don't think that I think it's much more likely that whatever caused the expansion in the beginning will, the universe will expand, gravity will pull it back. In fact, um, you know, so I think that it's just much more likely. It fits better. Now, it
Yeah, I
also
think so too.
it also fits a bunch of other theories too, like quantum dynamics,
Okay.
where a particle can be created and then disappear. You know, subatomic particles, according to quantum dynamics, appear and disappear all the time. Bigger particles can appear and disappear, but the bigger it is, the less likely. Theoretically, a particle the size of the universe could just appear. It's very, very unlikely, but we might be in the instance in which that one chance happened. Oh, what do we have?
Cliff says, I have met Brian Schmidt, Nobel Prize winner for dark matter and energy.
Ah,
Excellent.
um,
Oh, I missed one. So sorry. Dawns goes, it will be interesting to see where this goes. I agree with Jeff on dark energy.
yeah, yeah. I mean, I'm definitely going to be watching this because, I really, really want this to be true because it just fits so much better.
Yeah.
But my wanting, you know, you know, won't actually change the universe. So, we'll see. I don't, you know, if I'm wrong, it's what I felt about the accelerated expansion. I didn't want it to be, but hey, that's what the evidence seemed to point to, which I hated, but that's what the evidence pointed to.
Well, the more and better experiments we
Mm-hmm.
apply to it, the more and
Mm-hmm.
better answers we get. And then
Right.
we develop,
Right. And the
so many more questions.
the more assumptions we drop because we measure things like this one A supernova, the fact that their luminosity does vary based on the type of star that it generated, or at least 99.999% chance that that's what's going on there. So, I think that it's very likely that this is what's happening. The fact that there's still dark energy in the mix, well, as long as they take it to be just, there's something going on, we don't know what it is, that's fine. But the fact that they decided that it had to be this much because that's what fits what our other observations are is like, I don't like that. I don't like that flavor of science. I'd rather have, this is what we're measuring. We don't really know why, why it's like that. I guess too many people want to do their, papers and get published and stuff like that. So they have to come up with an answer. All right. But, and even these guys with the 1A supernova and the dark energy measurements that they've been doing here started to give an answer, which might be premature, but I'll take it. I'm just not going to believe it until more is done out there. But
makes sense.
But that article about the 1A supernova, that was published on the 5th of this month of November. And
really new. Okay.
Yeah, as we follow back on these growing evidence for
wait.
Yeah.
Let's share. There you go.
Because I started seeing stuff here in late June, maybe mid-June. Started seeing stuff about their evidence for dark energy changes over time. And it could inspire a new model for the universe. Basically, they didn't know what that meant necessarily yet in June. And this other article here, if dark energy if dark energy is decreasing, is the big crunch back on the menu? Here is, they were like, if it's actually decreasing, then the big crunch might happen. And here they're saying pretty much, yeah, it looks like dark energy is decreasing and the big crunch is likely. And here they say, hey, the 1A supernova, if you factor in to affect this thing, well, hey, it means that something's going on that matches the time varying dark energy, which means that dark energy is decreasing. And so I think that we need to, if one or two more things out there that either fit this model or break this model, that's, but I want to see more evidence, or I want to see it broken.
Yeah.
But I like it so far, but I don't trust it yet.
Okay.
And I think
it's okay to break these models.
Yeah.
What I think ultimately what we're interested in is what's real, the truth,
right.
The truth of the matter,
or getting closer to the truth.
Yeah.
Because as
pretty sure the Earth is not flat.
Right. Yeah.
But there's some people who think it is.
As James Burke said, at every point in our history, we've known exactly how the universe works, and at every point in our history, we've been dead wrong.
We know how it works until we don't.
Yes, until something comes along.
Yes.
That basically means that we have to rethink everything.
It's great.
Yeah. So I think that this is another step. No.
Okay.
I'm not showing anything.
Okay.
This is another step, and I'm happy for this step because I think we had a misstep before. Because I think that there were a whole bunch of people that made lots of names for themselves for simply coming up with going down this path. Kind of like string theory, which was very popular, became not as popular. There's still like little bits of, well, hey, if we use this bit of string theory, it fits these other models. It basically fixes some of our models. Now, does that mean that string theory itself is true, or just some of the math that they developed in string theory, is good math that can fit other things? That I don't know enough about. I have a while back, I had done enough research to have an opinion on it. And now it's been so long that between what I've forgotten and what other stuff they've come up with, I don't know.
Yeah, that's the thing. There's always more research, experiments, all kinds of things being done.
Oh, one of the things, and I forget which article, but the Vera Rubin was used to measure the dark energy that led to figuring out that that the universe isn't going into an accelerating expansion. So, the Vera Rubin, which we did the, so you might have helped show that by doing the citizen science on it. So that's,
yeah, those projects actually lead to real science.
Yeah. So if you are a really, really big fan of the accelerating expansion and the big rip end of the universe, sorry, we ruined it for you with Zooniverse.
Well, you sit here and think like it could happen. I guess if you blow up a balloon hard enough, it expands to the point where it can no longer hold itself together. It will, in fact, blow up.
Yeah. Then you had to get really creative then of where did the universe come from if this is what's going on?
I still wonder.
I don't know that we'll ever know.
I think it would be very hard to really know.
Well, we're inside, we were developed inside a three-dimensional universe, or at least three that we can measure easily. I don't consider time to be a valid dimension because it's like a half a dimension because you can only go in one direction really. But
your imagination can go everywhere.
Right. Yeah. But we were developed in a three-dimensional universe. I don't think we can develop the science to see what was outside our universe before the universe existed.
Yeah, I heard something last week that I thought was kind of useful for this. You can't read the label from inside the bottle.
Yeah.
I thought that was very good. Okay, yeah. Cliff says, yeah, there are a lot of people who have no clue about anything but come up with some crazy ideas. Yeah, I never understand how you can form an opinion with something having no idea what it's about. People have talked to me about, oh, that's a horrible thing. I'm like, have you, like books, have you read it? No. Okay.
Yeah.
Interesting.
That makes you an expert.
No.
Yeah. But
not in my opinion.
Now, of course, you can do a lot of studying, and if your ideas don't agree with everyone else's, you can be a crackpot until 20, 30 years later. Yeah, you're not. Yeah. We've had a number of those.
Oh, yeah. Yeah, there's, breaking stuff all over the place. Let's see, there's a good term for that. I forget. Yeah, what do you got?
Cliff says, imagine asking a flat earther about this. I'd rather not, Cliff.
I met one. That was fascinating.
I've talked with a flat earther before.
Oh, you have?
Yeah.
I didn't know that.
And I lost brain cells during the entire conversation. It was just like, oh.
Yeah, I prefer talking to people who, you gather brain cells when you talk to them. Mm-hmm. They're out there too.
Yeah.
Oh, Cliff is. Don't laugh too hard, buddy. All right. Okay. Anything else for us?
No, that's about it. It's
still sort of new.
Yeah, it's still sort of new. Don't have a lot on it yet. Okay. I mean, the things that I did find kind of go back in time to, when they were still talking about the dark energy. Okay. Found lots of articles on that, but I figured I'd just follow that one trail because it's representative of everything else.
Okay. Got it.
The standard candle thing, unless you want to read the actual study, the actual paper generated from it, which I don't, quite frankly. I'll take it.
Another crunchy topic?
I'll take it secondhand. No, I'll let Anton do it.
Okay.
He likes that sort of thing. I'll listen to Anton after he's read it.
I see. Okay. All right. So I just want to let you know that Everyday Spacer is sponsored by CV Computer and IT Solutions. Some stellar events this week. We're talking about November 21st through November 28th. The 21st, Mars and the Moon are in conjunction. And Uranus is at opposition. Sun, Earth, Uranus. That's what opposition is. It's opposite the sun from us. November 20th. Not
standing there with a sign saying,
I oppose this.
No. Down with Earth, yeah.
No. November 22nd, the Moon runs low. November 24th, Mercury and Venus are in conjunction. November 25th, Pluto and the Moon are in conjunction. Hard to see, though. Also, the Andromeda's meteor shower happens. The peak is the 25th through the 27th. These vary every year a little bit. This is going to be after midnight. Typo. 5 per hour are predicted at its peak. The comet source is Biela. Now, the moon sets really early right now, so this should not interfere with a meteor shower after midnight. It's going to be first quarter moon in a couple of days. So, in fact, it's coming up. November 27th, we have Thanksgiving here in the United States. It's a big celebration here, big deal. November 28th is the first quarter moon, and the moon is at apogee. Also, Saturn is stationary. November 28th is our Friday night show. And since Thanksgiving is the day before, we will appear on the live show as always, but we're going to keep it kind of casual this episode. Maybe we'll talk about what we're grateful for. If you want to think about that too, that would be wonderful. You can find us Fridays at 9 p.m. Pacific time on the Everyday Spacer, well, maybe the Facebook page, because it didn't work out tonight, and the Everyday Spacer YouTube channel. So it's really just easier to find us here anyway. I think I'll go and try and figure out why we're not actually showing up on Facebook. But what inspires you the most for the coming week? I do want to talk about some requests for show topics. We got one recently. I think I'll do that in a couple of weeks. And Isaac Arthur wrote to me again on LinkedIn. I didn't read it yet, so I think he'll be a guest eventually. Yes. I just love that very distinctive voice too. That's gonna be a whoop. So what would you like to see during an episode, or what do you find challenging? Kind of want to throw around a little bit and see what we can figure out from it. Let's see if we can go there for you. Yeah, we got a comment.
Yep. Janie said, thankful for Jeff, Pam, and Jeff and participating everyday spacers. Yep.
Thank you very much, Janie. We appreciate you too.
Yep. And Naomi, sounds nice.
Oh.
I wish we had Thanksgiving in Australia. The food always looks amazing. You know,
It can be amazing.
doesn't mean you can't do it.
True.
You know.
Can you get turkeys there? I don't know. Or some kind of bird.
Yeah, you can. You know. Just pick a day, decide it's a feast day, and
Yeah,
just do
or
it.
even do it at around the same time. And here's the thing with the online now, you can get all kinds of recipes, find out what's a traditional turkey dinner. But of course, everybody has their own specialties. I think the green bean casserole shows up a lot, and sort of typically you get cranberry sauce, and you've got the debate whether it's going to be the clear stuff or the fruit-filled stuff.
True. It says true.
You have turkeys.
We have
Okay.
turkeys. Good idea, Jeff. Oh, okay, cool.
Yeah, even if you try one thing or a couple things.
Yeah. Well,
oh, good. Yeah, the crunchy topics, good.
Yeah.
Yes, we like them too.
Yeah.
So you wanna take us out?
Okay. If you or someone you know has done something interesting involving space exploration, science, or astronomy, we'd love to share our live. Join us again next Friday, November 28th. We'll be here hanging out for a while and basically telling you what we're thankful for. And so happy Thanksgiving.
Happy Thanksgiving, folks in the United States. And if you want to celebrate other places, like they say in Canada, fill your boots. So we had Dawn here, and Naomi, and Janie, and Cliff.
And Scott.
And we did have, I'm just going to give it a shot here. Mohad Fahad?
I think so. Yeah.
You can always correct me if you want to. No problem there.
Yep.
I think we got everybody. Great having you here. It's always a better show when you are. Thank you so much. And you're good. Anything else from you? Oh, I see another comment. Let's see what we got here. Oh, thank you.
Oh,
Oops.
we both hit it.
One should do it. Yes. Thank you, Naomi.
Yep.
All right, folks. Have a great week.
Good night.
We'll see you next Friday.
Yep.
Good night.
Good night.